Hi YouTube, this is my first video tutorial for showing how to program a smart relay at Zelio Logic 2 especially. This is our first screen of the first window of the software that we will use to program the Zelio Logic. We will choose to create a new program. The others, it's easy to understand what it is. Here we will open, from this window we will open an existing program from this recently used program. This options is an interesting option that we can download a program from a module to our computer, and we can process with it. We can change things, make a new, add more code, remove code, or whatever we want. And here's the something more interesting. It is the monitoring mode. Here we can see what happens with the inputs and the program of the relay while the smart relay is working. Zelio is a very powerful smart relay, and we have the ability with this to make many applications. Let's begin. Here in this screen we choose the model of the Zelio. Personally, I choose the SR3 models because they are expandable, and the 24 DC models, also the 12 volt DC models, are have analog inputs, so it's easier to make more applications with them. Many inputs, many outputs, 6 analog inputs that can be used as discrete inputs. Let's choose this model. At the next screen, the software says us if we want to add expansion module to the Zelio, but we will not disturb about that this time. We will see what happened with them at a next video. We'll push the next. The software says us what language you would like to use for programming. Ladder of FBD. Personally, I choose FBD. I like it more. I believe it's more easy, and so I will use this for this video. I will make a video for the ladder language, other videos, but let's choose this. This is what we will use to program at this video, this language. Let's push the next button. Our first program will be a simple motor starter. We will use 2 buttons for start and stop the motor, and 1 contact for the overload protection of the motor. Let's put in the inputs. Here is our first input. We will use the I1 input for the start button, start. We will use this picture to represent the start. Here will be the stop. And we will use the overload. We'll use the overload contact. Let's name it overload contact. For our secrets, this will stop the motor when the motor is overloaded, our output will be a motor. Let's name it motor 1. Let's use the motor picture to represent it. First of all, the circuits that we will make must have these abilities for safety reasons and functionality reasons. First of all, we just press the start button and the motor will be running, will be rotating. Second, if we push stop button, the motor have to stop. If we press both start and stop button, the motor must be stopped always. If the overload protection contact it's energized, the motor must stop. And if it's stopped and if the motor is stopped and we push the start, if we haven't reset the error from the overload relay or whatever we will use to protect our motor, the motor must not be running again. So to make these simple circuits, we will use two logic function blocks. One is the AND block and the other is the OR block. The AND block is the block that will drive the PLC output. This is what we will drive. We will have a feedback to the OR function block, which needs to remain the motor output to be energized when we stop pressing the start button. Let's display the commands to see what is every button and every input or output. So in the OR function block we will drive the start button. At the OR function block, from the OR function block the output of the OR function block will be the input of the AND function block, and the stop button and the overload contact will be inputs for the AND function block. Let's make it nicer to see what is everything. Here it is. Now we will simulate that circuit and see what happens if that circuit do what we want. Let's push the simulation button. Let's run the simulation. Always the stop button is a normal close contact, so must be pressed. So we'll try to follow a little bit the simulation. Also the overload contact is always a close contact when the overload protection is de-energized. I mean that the motor is not overloaded. So with this a little bit tricky way, we will simulate the circuit that we have made. So first thing we want is to push the start button and begin the motor rotate, or the Q1 output be high. So let's press for a little time the start button. As we see the motor begin to rotate, the output Q1 is energized. Here is the feedback. Using this feedback, the motor is the output QN is still energized. This is the reason we use that feedback. Now if we push the stop button, the motor must stop rotating. As we see, the Q1 is de-energized and the animation here it changes. If we have pushed together start and stop, the motor it won't begin. As we see, the Q1 is not energized, there's no way. If the motor runs and we have an overload to the motor, here it is, the motor will stop, and the motor stops as we want. If we still pressing that button and we have to reset the error of the overload of the protection relay, the circuit breaker, or what else we use to protect the motor we see that don't start. Now we reset the error and the motor start begin again. Let's stop it. Our next circuit will be again with one motor. We'll make a simple circuit for changing the rotation of the motor. See you then. Now let's stop the simulation and let's go back to the edit. Bye bye. I believe that my video will help you.